Welcome to Solutions Studio. This is a free series on C programming language. If you like these videos, please subscribe to follow along with this series. Also, please like and leave a comment and share the video to help spread this series.
Hello and welcome to this episode, and in this episode we have an exercise for you, that is to create a selection sort algorithm. So a selection sort algorithm for a one-dimensional array has the following steps. First, the smallest value in the array is found. Secondly, it's swapped with the value in the first position of the array. And thirdly, the above steps are repeated for the rest of the array, starting at the second position and advancing each time. So eventually the entire array is divided into two parts: the subarray of items already sorted, which is built from left to right and is found at the beginning, and the subarray of items remaining to be sorted, occupying the remainder of the array. So write a program that sorts an array of 10 integers using this algorithm. So go on and try to solve this problem and come back to this video for the solution. Welcome back, and this is the solution to the problem that we discussed about selection sort. Now let's go and see how this solution works. Here we have defined a constant which is going to define the size of the array, and the size of the array is going to be 10 elements. Now we have three functions. The first function is the smallest value, where it will return the index of the smallest value in an array. The second function is the swap value function, which in an array that is given, it will swap between element 1 and element 2. Basically, if we are giving the subscript of two elements, it will swap between these two elements. And finally, we have a function for printing the array. Now, before going to the main function, let's go and see these functions. The first function is the swap value function. As we said before, it will take an array and it will take the subscript of two elements. And basically, it's going to swap between element 1 and element 2. So at the end of this function in the array, element 2 will be in the position of element 1 and element 1 will be in the position of element 2. Secondly, we have this smallest value function. This function takes an array, it will take the size of the array as well, and it will take a starting point for that array, a starting element. Now here in the smallest value function, we have defined the smallest element that we might have in the function as this value, and this is the biggest value that we can have for an integer. And we have also assumed that the index of that array is going to be -1 at the time until we find that smallest element. Now going on, we are going to start from the starting point that we have given for this function. For example, if the starting point is 0, this function will start looking from element 0. It will go until the end of the array and it will continue one step at a time. It will look into the value of each element and it will see if it's smaller than the smallest value, then it will assign the value of that element into the smallest variable, and also it will assign the index of that element, not the value of that element, but rather the index of that element into the index of smallest, and finally it will return the index of smallest. Next, we are going to have the print one-dimensional array, which is basically a function to print the array. And it will print the array along with the subscripts of that array. Now let's go and see the main function here. Here in the main function, we have an array, array1. We have these elements, 10 elements that are unsorted inside of this array. First, we want to print the unsorted array. We will use the print1d function to print the unsorted array. Next, we are going to start from element 0 and we will go until the end of the array, and for each element of the array we are going to find the smallest value. And basically the smallest value function will run starting from element 0 and then element 1 and then element 2, and during this transition from one element to other, it will find the smallest and it will swap the value of the smallest with the starting element. So if we start from element 0, we will see into the array that what is the smallest value in the array. Then we are going to swap the value of that smallest element with the starting element of the array. Now that we have the smallest element at the beginning of the array, we will have the starting element at position 1. And basically we leave the sorted part behind and start from the unsorted part. And going on, we will continue doing this until the whole function is going to be sorted. Now let's go and execute this program. And as you can see in here, this is the unsorted array that we had in here: 12, 45, 67, 43, 45, 87, very unsorted array, and at the end we will have our sorted array: 5, 12, 32, 34, 43, 45, 45, 67, 87 and 100, and basically the array is properly sorted. And that's it for this episode. I hope this has been informative for you, and I would like to see you in the coming episodes. Stay tuned.